Welcome. Yesterday, due to rain, I could not upload the class or could not record the class. Okay, now, new part today. Centroid G for lamina in the form of circle or semicircle or quadrant of a circle. See, either circular lamina or semicircular lamina or quadrant of a circle. You can either tell lamina or you can use the word for area. See, lamina means plane area or structural engineering. It is a cross section of member. Okay, leave it. I already told it. Now, first make some note. First of all, I am writing something and explaining now which are actually high school level. Not high school. Nowadays it is even not high school. Much before high school I think. Okay. But why I am telling reason is there. Sometimes people get confused. Little. Especially for area, radius and diameter both are there. Sometimes expression may be in terms of diameter. Sometimes expression can be in terms of radius. So, first make primary part. Simple mathematics. For all three, circle, semicircle or quadrant of a circle, whichever you want, diameter is twice of radius or radius is diameter by 2. Everybody knows about it. I will show my sketches. So, let the capital R be radius. One small note you can make here. For radius, I am using capital R. There is a reason. Because later, when you derive expression for centroid, suppose a circle is there. See, I can take radius capital R, small r. You have take an elemental strip here. At radial distance r, oh see, this is r, it can't be r. So what I will do? For derivation purpose, I will take capital R. Later, when you write final summary, you write either capital R or small r. Okay, we will stick to capital R. And also, see, in torsion theory also, when you want maximum shear stress, you have to come to outermost fiber, capital R. When you want shear stress somewhere here, it is distance of that element from center, small r. So it is better to take capital R as radius, diameter, either you can take capital D or small d. See, but I am used to take throughout my teaching small d, so I won't change it. I will take small d only. No one should question, sir, why you want the capital R for radius and small d for diameter? Habit. If you want take capital D, no problem. So diameter equal to twice of R radius or radius equal to diameter by 2. Now, one small information, actually not required. Where is diameter? See here, I will show it. Not required. See, first consider a circle. Circle. See, this is this side. This all make a note. Circle. This is circle. Now here, this is the diameter D. This also is diameter D. Even if you project this way, see, any direction, this also is diameter D and this is center. I think forgot one. See, let throughout calculation C be center. Center for circle. See, this is center C. C is the center. This is crystal clear. Now, where is radius? See, this is radius R. R. This is radius vertically R. Or even inclined also. Anywhere you can take. Even this way also you can take. It is radius. So therefore, diameter equal to twice of radius or radius equal to half of diameter. Crystal clear it will be. I think further not required. And make a note here. In a circle, you can see the radius and you can see the diameter and also radius. Radius everywhere visible, circle radius visible and also diameter visible. Okay, now consider a semicircle. See, semicircle. Semicircle. See here. Here, semicircle. Do one thing. D is the diameter. Dia. R is the radius. Where is C? This is the center. As usual I told, C is the center. Center for circle. Okay. Now, see here, this is center. This is your diameter. All right, right, anywhere? Okay, see. This is your diameter. And this way you can see diameter. This way you cannot see diameter. If you want to see the diameter, what you have to do? Imagine the extension here. Then see, this will be diameter. Diameter. Radius. This is the radius. This also is radius. Even this also is radius. So once again, as usual, you can tell, I already told, d equal to diameter equal to 2 times radius, or radius equal to diameter divided by 2. This is quite simple. So in semicircle, as per this sketch, horizontally diameter you can see, but vertically you cannot see diameter. But semicircle can be other shape also. See, I will explain now. Or for example, see, everything I will tell. If the semicircle by chance is this way, then again, horizontally you can see diameter, vertically you cannot see it. But if the semicircle is by chance this way, either this way or it is this way, then vertically you can see diameter. See here, vertically you can see diameter. Horizontally you cannot see. If you want to see it, you have to extend here. You have to complete circle. Okay, it has gone out of limit. Okay, you have to extend the circle, then you can see the diameter. See, then this will become d. Very simple part. Come to next, quadrant of a circle. So semicircle, in circle in every direction you can see diameter. Radius is always visible everywhere. All three cases, circle or semicircle or quadrant, radius is visible. Circle, diameter visible in all directions. Semicircle, diameter visible only in one direction. Now come to quadrant. Quadrant of a circle. Quadrant of a circle. Of a circle. See, for derivation purpose, I will always take like this. See, the quadrant can be like this. I'll put it here this way, or it can be like this also, or even it can be like this also, or it can be like this also. See, anyway, quadrant. Now, this is center C. This is center C. This is center C. This is center C. This is radius. This is radius. 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 This is radius from here to here. From here to here is radius. See, from here to here is radius. This is radius. Here, where is diameter? Center visible. Here, diameter you cannot see. You write the sketches here. But if you are very eager to see the diameter, what you have to do? You have to extend it all round. See, this way. Now you can see the diameter here. This is diameter. This is diameter. Or here, extend it all round. Imagine, then this will be diameter. This also diameter. Or here, write one more sketch. See, extend this way. Other one, I don't have to explain. Okay. So, quadrant of a circle, radius visible, diameter is not visible, but you can imagine it. Even then, see, even then, when you imagine the diameter, this is diameter. Here also, diameter equal to 2 times radius, or radius equal to diameter by 2. Okay. First of all, somebody will tell. He is telling primary school mathematics. Okay, no problem. Let the people tell. He is unnecessary waste. Some will tell he is wasting our time. But one fine day or somewhere later, when you make a mistake, then you will realize, oh, he told for some reason. Okay, now this full I will remove. I will come to centroid now. See, now I will come to centroid. But before centroid, something else I want. Before centroid, something else I want, so that later there is no problem. See, everything I am going to tell in this today's is an introduction class. Derivation of center, look, see, for circle, there is no derivation. Center itself is centroid. So today title is what? Centroid for circle, lamina in the form of circle or semicircle or quadrant. Complete explanation. Next class will be derivation of expression for locating centroid for semicircle and quadrant of a circle. First approach. One approach is there. I will explain what is the approach now. One more class will be there where I will write again derivation of expression for locating centroid for a semicircle and quadrant, alternative approach, or there is an alternative method. I will explain all those today so that at that time I will tell. Suppose someone will tell, it is not clear, go back to the first class. First class means when I started introduction or explanation, first go there. Study everything, understand, then come here. You should not suddenly come to a class and tell nothing clear. And sometimes when you write area, people get confusion. Not all. See, now, first you consider area. Area. See, if it is a circle, actually very simple. See, circle. You write anywhere, diameter D, one place, and radius R. One place sufficient. This is center. See, area for a circle, you should know pi r square, or radius capital R. Okay. I am actually earlier writing small r. Pi r square. Remember, area for a circle is pi r square. Now, or replace r by what? R by d by 2. Then area equal to, see here, pi into d by 2 square is, this is the area for circle in terms of radius, area equal to pi by 4 of diameter square. So these two correctly you have to remember. See, right now you require for derivation purpose radius. Later, when you go to numerical problem all, I never use radius. In structure engineering, except some special cases where, see, like thick and thin cylinders, where fluid pressure considered, their internal radius required. People will tell pressure into, their internal pressure is there. Only such places, or sometimes where fluid mechanics part, there we use radius. Else, everywhere in structural engineering, people define by diameter. See, RCC, no one will tell 5 mm radius bar. They will tell 10 mm bar. See, suppose a bar of 10 mm diameter. Nobody will tell 5 mm radius diameter. Anything, even for quadrant of a circle, even if the diameter is not visible, our expression will be in terms of diameter. I will give a note later. So, over. This you have to thoroughly remember. Pi r square or pi d square by 4. Now see, semicircle, I will tell you why. Because when you require area later, you should not struggle. Semicircle. This is diameter d. And if this is center, this is your radius. See, this is your radius. So, here your area equal to pi r square by 2. Oh, sorry, habit. Earlier I was taking small r. Okay. Now I have to change it. Pi into r square by 2. Why? See, you remember here, circle, pi r square. Semicircle, half of circle, pi r square. See, same way later, when you go to quadrant of a circle, it later, see, I will write quadrant like this. Quadrant here, this is center, see, this is radius. This also is radius. I put here only radius, okay. This is radius. This is radius. Diameter you cannot see. If you want to see the diameter, you have to imagine the circle. See. Then this will become diameter. Here, area equal to circle is pi r square. Semicircle is pi r square by 2. area equal to pi r square by 4. So correctly remember, you start from circle, pi into r square, semicircle, half of that one, pi r square by 2, quadrant of a circle, 1/4 of the circle or further half of semicircle, pi r square by 4. Same way for circle, in terms of diameter, for circle, this everybody knows, pi d square by 4. So semicircle in terms of diameter or area equal to pi into diameter square by 8. Or you can do one thing here, replace r by what? D by 2. D by 2 square is d square by 4 into 2 is 8. And here replace r by d by 2 or your area will become pi d square by 16. Or you can maintain a, remember, see, radius if you want, in the mind, circle, pi r square, semicircle, see, look somewhere, think pi r square by 2, quadrant, pi r square by 4, okay. In terms of diameter, circle, pi d square by 4, semicircle, its half, pi d square by 8, quadrant, again half, pi d square by 16. Correctly remember. So later, when I derive expression, when I want area, I will not explain. If I want area for a circle in terms of radius, I will write pi r square. I will write area equal to, y means no question to be asked. Or if I want in terms of diameter, I will write pi d square by 4. When you come to semicircle, suppose I want area, I will write, we know that area equal to pi r square by 2. Or if I want diameter, in terms of diameter, pi d square by 8. Quadrant of a circle, suppose I want area, I will write in terms of radius if I want, pi r square by 4. Whereas in terms of diameter if I want, somebody will tell us diameter, where is it? Imagine diameter. Imagine pi d square by 16. Sorry, in future, these will not be explained. Okay, now I will go to centroid. First I will do one thing, I will explain centroid for a circle first. Then I will go for semicircle and quadrant. That is more important. First I will finish circle. Nothing is there. For a circle there is nothing. See. First comes here centroid. That is G. Centroid symbol is G for a circle. G. For a lamina not required. Okay. For circular lamina. Okay. Or simply circular spelling problem. Okay. Circular lamina. Lamina. See. Let R be the radius and D be, let D be diameter and let C be center. Okay, now see, a circle is always like this. See here, if I draw one axis here, this is center. See, diameter or later. See, this is axis of symmetry. Axis of symmetry. You write here. Next time I won't write symmetry. Even this also axis of symmetry. Actually, there are infinite axes are there. This also axis of symmetry. There is a rule I told. Make a note. I told one rule. For any lamina, if there is an axis of symmetry, centroid lies in the axis of symmetry. But if there are two axes of symmetry, then you don't have to locate centroid. It should lie in this axis and should also lie in this axis. Therefore, the center C itself is centroid G. That is, if there is a circle is there, the circle, if you tell diameter D, anywhere you mark radius, no problem. Anywhere you mark radius, just R, that is sufficient. Center C, comma, it is center and also centroid G. So it is a black dot with red dot coinciding, exactly coincides with center. So no location. Therefore, if you want, see, if this is 1 meter, I'll put this way. Okay, this is diameter D. So to make clear, see, this is radius R, radius R, radius R. Here also, this is radius R, radius R. This is diameter D. So this is radius R is D by 2 equal to D by 2 equal to D by 2 and D by 2. Suppose you want centroid distance from this reference axis. It is either you tell radius or tell diameter by 2. If you want from here, this distance, you either tell radius or tell diameter by 2. Same way. If I want from top edge here, centroidal distance, either you tell radius or diameter by 2. From here, if you want centroidal distance, it is either R, radius R or diameter. So these two will become your x bar. From extreme end, these two will become your y bar. So crystal clear, so easy. Or remember, centroid for a circle will be exactly at center. It will coincide with center. So if the center you call C, that itself is centroid G for a circle. Okay. Now come to most important, centroid for semicircle and quadrant. Here I have to prepare some sketches and thoroughly explain and then tell you how to locate it. Some theory. Now some theory will come. Now come to important part, centroid G for a semicircular lamina, little later centroid G for a lamina in the form of quadrant of a circle, or simple language, centroid G for semicircular area, centroid G for an area which is quadrant of a circle, simple language. Okay, now everywhere R is the radius, D is the diameter. Everywhere I wrote. See here, diameter you can see in one direction, radius you can see any direction. See, both direction you can see radius. This is radius. Or here, radius you can see here, here. Diameter you cannot see. If you want to see the diameter, you have to complete a circle. Then C is the center. Center means not midpoint. See here, center will come some, no, not that way. You write here, class. For a semicircle, center means center of the circle. If you complete a circle, see one side semicircle, other side introduce a semicircle, then together it will become a circle. Then C is the center. Here, C is not the center. Center means quadrant, anyone, quadrant. You introduce one more quadrant on other side, left side, and two more quadrant on right side, or all round introduce quadrants. Total, it will become a circle. For that, C is the center. Okay, now this is radius R. See, radius R. This is radius R. Sufficient. Now, I already told you, centroid G lies if there is an axis. Once again, write. If there is an axis of symmetry, centroid lies in that axis. See now, semicircle. See. It can be like this, it can be like this, it can be like this, it can be like this. Or quadrant, it can be like this, or it can be like this, it can be like this, it can be like this. Now, first come to semicircle. See, for semicircle, see, this is axis of symmetry. Why? Because both are same. Same way here, this is axis of symmetry. This is axis of symmetry. For circle, there are infinite number of axes of symmetry. All of them passes through center. That's why centroid is center. Semicircle, there is just one axis of symmetry. How? It will be perpendicular to the base. This way, see, perpendicular. This is the base. Okay, then for a quadrant of a circle, there is no axis of symmetry. First of all, symmetry word is not there. See, there is no symmetry here. So quadrant, there is no symmetry. Now, since I told this is axis of symmetry, centroid will lie in this axis. But now, therefore, if you want this way and this way, it will be r d by 2. See, so this will become your x bar. This will become your x bar. X bar. Here, this will become, I won't write once again. This is y bar. See here, this will be y bar. This will be y bar from reference. Here, this will be your x bar. This will be your x bar. Here, this will be your y bar. This will be your y bar. So, now centroid lies, see, actually now, see here, since the area is here, more area is this side. So centroid will lie here. This is centroid G. See here, this is centroid G. This is centroid G. This is centroid G. Now, this distance you have to calculate. This is x bar, not required. See, exactly midpoint. This is your y bar. Here, see, this is your x bar. Here, this is your y bar. Y bar. Here, this is your x bar. So, make a note. For a semicircle, among x bar and y bar, one of them is fixed by symmetry. See here, symmetrical about vertical axis. So, this distance is half of diameter or radius. This distance you have to calculate. So, this y bar you have to calculate. Here, y bar is not required, center. This x bar you have to calculate. Here, this y bar you have to calculate. This here, this y bar you have to calculate. This is not this y bar, otherwise y bar is known. X bar you have to calculate. This x bar you have to calculate. Y bar is known, y bar is known, y bar is known. See, x bar is known, x bar is known, x bar is known, x bar is known. Now, therefore, for a semicircle, you have to find only if it is this one among these two, you have to find, see, y bar and y bar. If it is one of these two, you have to find x bar. Actually, whatever y bar you get, same x bar will come here. So, later you will be knowing that this y bar, I will put color change, will come 4r by 3 pi or 2d by 3 pi. It will come. You write here. Rounded means I am giving anticipatory answer. It will come. Then this x bar also will be either, either 4r by 3 pi or 2d by 3 pi in case of diameter. Here, this y bar also will come 4r by 3 pi or 2d by 3 pi. It will come. This x bar also will come 4r by 3 pi or 2d by 3 pi. So, for a semicircle, centroidal distance, one of them is fixed exactly midway. Other is at either 4r by 3 pi or 2d by 3 pi. We have to get it now. That is next class. So, therefore, you don't have to waste time for y bar, x bar. In the class, for derivation purpose, see, class, we will consider this sketch for derivation. See, when I derive next class, I will take semicircle this way. I will prove that y bar equal to 4r by 3 pi or 2d by 3 pi. Then summary class, I will write same answer here, same answer here, same answer here. Okay. So this is the sketch I am using. So next class, when I locate centroid for a semicircle, I will write, let us consider a semicircle as shown in the figure, for which distance along the base is not required. Centroid distance is exactly midpoint, that is from extreme ends, radius or half the diameter. Other distance, let it be y bar, we will go for integration and get the answer. Okay, now centroid for lamina of quadrant, there is no axis of symmetry. Therefore, here, see, more area this side, more area this side. Your centroid will be somewhat near here. See, this is centroid G. Here, this is centroid G. This is centroid G. We will prove it. This is centroid G. Now, here, this I will call X bar. This I will call Y bar. Here, this I will call X bar. This I will call Y bar. Here, from the baseline, see, this I will call X bar. This I will call Y bar. For standard derivation, this I will call Y bar. This I will call X bar. So, semicircle, you need either only X bar, Y bar is fixed, or only Y bar. We will go for Y bar. Here, therefore, we need both X bar and Y bar. Right here. But you need not waste time doing both of them, because if I turn here, X bar will become Y bar will become X bar. But we need not find both. We need not derive expression for both. Derive expression for both. Just any one of them to be derived, because your X bar will be equal to Y bar. Later, you will, for all these cases, you will get X bar equal to Y bar equal to same as that answer. In terms of radius, I'll use green color. It will come 4r by 3 pi, or in terms of diameter, it will come 2d by 3 pi. I will get it. That is same as this answer. But here, one of them is 4r by 3 pi or 2d by 3 pi, other is center. Here both are same. And now, in the class, when I derive the equation, any one of the 4 sketch required, I will consider this sketch. See, I will go this sketch. Then, when I consider this sketch, I will not waste time finding both X bar, Y bar. I will write X bar, Y bar, I will show. Let us find Y bar. Derive the expression for Y bar. We will get 4r by 3 pi or 2d by 3 pi. Then I will tell, we know that X bar is also equal to Y bar. Therefore, I will put a sketch. I will tell Y bar equal to 4r by 3 pi or 2d by 3 pi. X bar also equal to 4r by 3 pi or 2d by 3 pi. I will do that way. Okay, now we will go for derivation. For derivation of the expression for locating centroid for a semicircle or quadrant of a circle. I'll start fresh for that one. Some theory I have to give for that one. Some principles are there. That's why I told, if you skip this class and directly go to next class where I am deriving, if I write consider a strip this way or consider an arc form, you will ask why. Why means I will tell why not you have gone to other class. If you want to study thoroughly, everything I explain here, you have to understand, and then only you can start. Directly, see there, I can't waste time on telling strip. One place we will take a horizontal strip. In another case, we will take a circular strip. A strip in the form of an arc. I will tell you why, reason. I will explain that one, and we will be ready for derivation. I will make everything ready for derivation. So next class will be derivation. Remember, 2 approaches are there. I will explain both the approaches for you. Whichever you feel comfortable, you can go for it. Suppose there's examination. They ask you, derive expression for locating centroid for a semicircle or quadrant of a circle. You can go for any approach. I will first go for one of the approach, first approach. Then I will tell, you can derive in some other way also. Both are finally everywhere, answer will come same. Okay, I will prepare the sketches. Now, some explanation. Class, we are going for derivation of expression for locating centroid G for lamina either semicircular or in the form of a quadrant of a circle, both. There are two approaches. I will tell approach 1 and approach 2. Remember, both are easier, but I feel approach 1 is much more easier. But integration, you need little extra effort. Approach 2 is little confusing. Not for me, confusing, but integration is easier. One place advantage, one place disadvantage. Okay, I will first tell approach 1. Approach 1, see, approach 1 is our regular approach. Our regular approach. Semicircle, see, remember, this is, I already told, this is y bar, this is not required, this is all I told, y bar. Here also, y bar, x bar, we will find y bar. See here, once you get y bar, this is half the diameter or radius. Here, whatever y bar you get equal to x bar. So, in our class, for both of them, we will consider y bar. Okay, now, some class, I am telling statement here now. See, you should write. For both of them, what I will do is, see, I will write here. For both, see, now, class. For both, okay, for both means semicircle and also for quadrant, what we will do is, see, green color, consider elemental strip of thickness. Remember, if you want to y bar, thickness should be dy at y as shown, y from base. Okay, y, I will call this as the base, or I will call this as AB line. This I will, okay, I won't call AB line because center will come. No, y bar, that much you can make out, y at y from base. You do one thing, you imagine this is the base. This is the base. At y from base, see, at y from base, strip, elemental strip of thickness dy. Then I will write, let b dash be width of the strip. Width of strip. And we will get b dash in terms of y. I will tell you how to get it by trigonometry. Using trigonometry. For both the cases, see here, full strip, we will get that b dash in terms of y. Then area of elemental strip, dA, you can, since it is a very, very small strip, you can take it as a rectangle equal to, for both the cases, b dash into dy. See, b dash, see, these all ignored. It's a very thin and very, very small. So b dash into dy, here also b dash into dy. Then y bar, you know the formula. Y bar equal to integration of dA into y by total area. This is what we have done for triangle and also for trapezium earlier. Basic derivation, simple approach. Only problem is during integration you require method of substitution. You get root of r square minus y square, r square minus y square, and outside y will come. Some we will put let r square minus y square equal to t, differentiating we will write 2y dy equal dt. That all I will tell in the class. So this is a very simple approach, very easy approach, but integration has got little problem, not a problem. I will clearly explain the integration for you. So this is traditional. You will get answer for both y bar, both the y bar, you will get in terms of radius, you will get 4r by 3 pi, or you get 2d by 3 pi. This is traditional approach. Approach number 1. This I will complete in the next class. There will be one more class. Title will be alternative, or I will put approach 2, or I will write alternate approach. Something I will write there for derivation. Okay, now I will explain to you what we will do in see this full you write here. So later when I go to approach 1 for semicircle and quadrant, these all I will not tell. I will just write here. Let us consider elemental strip, etc. Doubt, people get doubt. Hey, last time he told elemental strip. When I go to approach 2, what he is doing now? He is taking a circular arc. I will tell, go back to the introduction class, understand, and then come. Okay, now I will tell you approach 2. This I have to write, not regular. This is somewhat special. Special, little tricky, not tricky, little tricky, but integration is very easy. Very easy. Okay, I will just prepare the sketch and explain to you. Approach 2. Now come to approach 2, little tricky, but integration very easy. Okay, semicircle and quadrant. First do one thing, as usual. This is y bar, x bar not required. This is y bar, this is x bar equal to y bar. This I told. Both the places we are finding y bar only. But remember, what we will write is, for both of them, see, what we will do is, I write here, what we will do is, we will consider elemental strip in the form of an arc. See here, in the form of an arc, this way, elemental strip arc, where at radial distance small r from center. See, from center small r. See, this is capital R. From here to extreme is capital R, up to here is small r. And let thickness equal to, see, since it is r, thickness is dr, and area equal to dA, and let ds be arc length. Then your dA will become element ds into dr. For both the sketches, see, same. And we will take this arc, elemental strip in the form of y-axis. See, everything. Let the strip be at y from base. This is y only. See, this is y from base. Because when you want to y bar, you should take y. But what we will do is, there is no dy here. What we will do is, your formula for integration is what? Integration of dA into y by area. Then there is no dy here. Then for both y bar equal to integration of dA into y by area. That remains same. But what we will do is, our integration is, see, what we will do is, this y all will convert to r and theta. Let the angle be theta. I wrote the angle somewhere. Okay, let the strip get y from base, and let theta be angle from OX axis. You call this as OX axis. See here, OX axis. This is angle theta. And also we will write, let d theta be angle subtended at center for this elemental arc. Sometimes student will have doubt. Sir, it is y up to where, sir? Here or here? No, nothing like that. From here, anywhere here, y angle is theta. Is theta up to here or up to here? Theta. Because I will tell you, this is exaggeration. This is elemental. Means what? Very, 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 very small. ds is very, very small. dr is very, very small. dA is very, very small. d theta is very, very small. Further, I will explain later. Or to understand correctly, I told these are all elemental. Therefore, if you want correct understanding, see what I am doing. I will tell for this one now. See, it is actually how is it? See, now you can imagine what? See, suppose you take semicircle, just to understand. See now, this is called mathematics. Okay, see what I am doing. Center, see. My over, see, elemental arc. Now see, theta r y. Here, this is very, 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 very small. That is, if you exaggerate this one, it will become what? It will become this is d theta, this is r, this is your dr, this will become your ds. If you exaggerate, otherwise, very, 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 very small. So you cannot make out. See, actually not this much also. Strictly speaking, not that much also. See here. Strictly speaking, see here. Over. It's a point. So that's all. All this, what I wrote here is exaggeration. So this is your y and this is your theta. Limit for theta, limit for r, I will tell you next class. That all I will tell next class. So this approach to, see so many books you can see this one. They won't explain all these things. I will tell what they will write. They will write area equal to, they will write r theta into dr. Y and into y is r sin theta. Without explaining, I will explain the concept. So remember, this is exaggeration. It is like, see, I am staying in Bangalore. See, Bangalore area is like this. Okay, imagine our greater Bangalore. So many places are there, maybe so many kilometers. If I see Bangalore map, it is like this. But if I put Bangalore not in the world, in the entire galaxy, how it will be? Even galaxy, in the entire galaxy, if I mark Bangalore, it won't be even a dot also. No. In Karnataka state, if I belong to Karnataka, Bangalore will be something like this. See, in Karnataka state, like this. In Indian map, it will be smaller. In the world map, Bangalore will be a dot. In the universe map, our solar system map, it will be further smaller. In the galaxy, it will be not even like a dust of sand piece compared to entire our universe. See, we are like what? Like very, very, see, people, they do so many things. They don't understand. Where we are nothing. In front of the entire universe, you are nothing. This is the principle of integration. Okay, sufficient. Further, I will explain in the next class. For next class, I will do approach 1 for both because that's advantage for me. It will save time. I will finish approach 1 for both. Those who like it, go do that way. Then other class, one more class, I will tell alternate approach, or I will put approach 2. Tomorrow I will write approach 1 for derivation of centroid for semicircle and quadrant. Next class I will upload approach 2 of derivation of expression for centroid, locating centroids for semicircle and quadrant. Okay. But I will tell in both the classes, if you want to thoroughly understand everything, what all introduction I told you should go through. Otherwise, if you get confusion, it is your problem, not my problem. Okay, thank you. Hope you will really go through everything and understand. That is my main purpose.